Hi students, welcome to Future Doctor NEET Academy for the crash course in NEET Physics. Topic today we are going to discuss is from chapter 7, 8, 9. This is chapter 7, System of Particles and Rotational Motion. In system of particles there is an important term, center of mass. What is center of mass? Center of mass of your body is a point where the entire mass of the body can be supposed to be concentrated. That is called center of mass. What is center of mass? It is a point where the entire mass of the body can be supposed to be concentrated. For a system of n particles, n number of particles, the center of mass is given by R equal to, R vector equal to M1 R1 plus M2 R2 plus M3 R3 plus up to Mn Rn divided by M1 plus M2 plus M3 up to Mn. And this can be simplified and write as summation I equal to 1 to n, summation I equal to 1 to n, Mi R1 vector divided by M. Here capital M is the total mass. Okay. Note down this formula. This is the center of mass. Noted? Torque. The turning effect of a force with respect to some axis is called moment of force or moment of couple or torque. Okay, it's denoted by a symbol. What's the symbol? Tau. It should be read as tau. Turning effect of a force with respect to some axis is called moment of force or moment of couple or torque due to force. Torque is measured as the product of the magnitude of force and perpendicular distance of the line of action of force from the axis of rotation. Simply torque or moment is nothing but force into perpendicular distance. That is only torque or moment. Force into perpendicular distance, the distance only r. Tau equal to r cross f. This is a best example for cross product or vector product. That is both r and f are vector and resultant tau also vector. Tau equal to r cross f. Okay. Next term, angular momentum. Angular momentum is the rotational analog of linear momentum and is measured as the product of linear momentum and the perpendicular distance of its line of axis of rotation. Linear momentum, you studied this in mechanics, there is a loss of motion and all, and this is angular momentum. Linear momentum is for straight line motion, linear motion, and angular momentum is for rotational motion. Mathematically, P is the linear momentum and R is the position vector. Then angular momentum L equal to R cross P. This is the another example for cross product. L equal to R cross P. R, P, this is also a vector and that resultant also vector. L equal to R cross P. It is SI unit, kilogram meter square per second. Okay, that is the momentum is kilogram into meter per second and R is meter, therefore kg m square s power minus 1. That is the SI unit of angular momentum. Symbol for angular momentum L, capital L. Relation between torque and angular momentum. Tau equal to dl by dt. Tau equal to dl by dt. Lot of problems we will work out based on these things. Tau equal to dl by dt, and if the system consists of n particle as then L1, L2, L3, L4, then tau equal to dl1 by dt plus dl2 by dt plus dl3 by d3 up to dln by dt. This formula gives the relation between torque and angular momentum. Next, law of conservation of angular momentum. What is conservation? Constant. Law of conservation of angular momentum, like energy, angular momentum also constant. When? If no external torque acts on a system. If no external torque acts on a system, then the total angular momentum of the system always remains constant. Okay. No external torque, that is if tau equal to 0, then L is constant. That is L1 plus L2 plus Ln or L total is a constant. This is the law of conservation of angular momentum. It's same like law of conservation of linear momentum, law of conservation of energy, like that. Total momentum is constant. Total angular momentum is constant. Next term, moment of inertia. Moment of inertia is denoted by a symbol I, capital I. And it is moment of inertia of a rigid body about a given axis of rotation is the sum of the product of masses of the various particles and square of their respective perpendicular distances from the axis of rotation. Simply I equal to mr square. That is a simple formula for moment of inertia. I equal to mr square. And mathematically I equal to m1 r1 square plus m2 r2 square plus m3 r3 square up to mn rn power 2. That is equal to summation I equal to 1 to n mi ri square. It gives for n number of particles. Suppose it contains 10 particles, then I equal to 10. m1 r1 square plus m2 r2 square up to m10 r10 square, like that. And SI unit of moment of inertia kg m square. Unit of mass kilogram, unit of distance meter. So kg m square is the SI unit of moment of inertia. What is the dimension formula? Dimension formula for small m is capital M. Is it so? Dimension formula m and then L power 2 or minus 2? M L power 2. Okay. This is the dimensional formula for moment of inertia. And mi corresponding to mass of the body. Moment of inertia correspond to mass of the body. That is, in linear motion, what mass is doing? Same thing in rotational motion, moment of inertia. Okay. That is, in linear motion, velocity as linear velocity, and angular motion, angular velocity. In linear motion, displacement is S, in angular displacement theta. Just like that, in linear motion mass, in angular motion or rotational motion, moment of inertia. And moment of inertia depends on shape and size of the body and also on position and configuration of the axis of rotation. It depends upon the shape, also size, and also position and configuration of the axis of rotation. That is towards the center of gravity, against the parallel to the center of gravity, like that. Based on that only, parallel axis theorem, perpendicular axis theorem, that and all we will discuss now. One more term, radius of gyration. Radius of gyration of a body about an axis of rotation is the root mean square distance of the particle from the axis of rotation, and its square when multiplied with the mass of the body gives moment of inertia of the about the axis. K equal to square root of r1 square plus r2 square plus up to rn square divided by n. Root mean square value of the mass of the body, that is the radius of gyration. And there is a relation between radius of gyration and moment of inertia. That is I equal to m k square. Okay, I equal to m k square. M is a mass and k is the radius of gyration. And I is the moment of inertia. Okay. Two theorems we will use to determine the moment of inertia of a material, rotational body. One is perpendicular axis theorem. It states that the moment of inertia of a plane lamina about an axis perpendicular to its plane is equal to the sum of the moment of inertia of the lamina about any two mutually perpendicular axes in its plane and intersecting each other at a point where the perpendicular axis passes through the lamina. That is mathematically Iz equal to Ix plus Iy. This is Iz. We want to find the moment of inertia of the Z axis, for example. That is equal to Ix, moment of inertia along x axis, and moment of inertia along y axis. Iz equal to Ix plus Iy. Here, x and y axis lie in the plane of the lamina, and Z axis is perpendicular to its plane. There is a lamina is just a thin sheet, thin layer. Okay, and x and y is along the line of the plane, and Z will be perpendicular to the plane. Okay, plane and passes through the point of intersection of x and y axis. Write down the formula for perpendicular axis theorem. What is the formula? Iz equal to Ix plus Iy. Okay, Iz equal to Ix plus Iy. So based on this, we will determine the moment of inertia of some material having different shape, and we will work out the problems also. We are going to apply both the axis theorem, perpendicular axis theorem, and the next one will be parallel axis theorem. Noted? Parallel axis theorem. It states that the moment of inertia of a rigid body about any axis is equal to moment of inertia of the body about a parallel axis through its center of mass plus product of mass of the body and the square of the perpendicular distance between the axes. That is I equal to IC. IC is the moment of inertia passing towards the center of mass. Just like center of gravity here, center of mass. And plus M into, M is the mass of the body, whole mass of the body, into perpendicular distance between these two. Suppose we want to find the moment of inertia of ED. As per the diagram, we want to find the moment of inertia of the plane passing through ED. Okay, then this is equal to sum of the moment of inertia passing towards the center of mass, that only AB as IC, plus mass, product of the mass, M is the mass of the body, into distance between these two. Distance between these two is H. Some place R also will be given. If instead of H, R is given, I equal to IC plus M R square. Some place IG will be given as a center of gravity or center of mass. So I equal to IG plus M R square. Like the different value, different symbol we will use. But I equal to IC plus M H square. And here IC or IG is the moment of inertia of the body about an axis passing to the center of mass, and H is the perpendicular distance between the two axes. And this formula is for moment of inertia for this ED or DE axis. Okay. Moment of inertia of a few bodies of regular shapes. Moment of inertia of a rod about an axis through its center of mass and perpendicular to rod, that is I equal to 1 by 12 M L square. L is the length of the rod, M is the mass of the rod. What is the shape of the rod? Cylindrical shape. So it's a moment of inertia of a cylinder, rod or cylinder. I equal to 1 by 12 M L square. Next, moment of inertia of a circular ring about an axis passing through the center and perpendicular to its plane. I equal to M R square, capital R square. R is the radius of the ring, circular ring. And moment of inertia of a circular ring about an axis passing through its center and perpendicular to its plane. I equal to half mr square. For ring, I equal to mr square. For circular disc, 1 by 2 mr square. Next, moment of inertia of a right circular solid cylinder about its symmetry axis I equal to 1 by 2 mr square. Next, moment of inertia of a right circular hollow cylinder about its axis mr square. Hollow cylinder for that mr square. Hollow means inside will be empty. Example, water pipe. Water pipe we can say hollow. Moment of inertia of a solid sphere about its diameter I equal to 2 by 5 mr square. And moment of inertia of a spherical shell about its diameter I equal to 2 by 3 mr square. I equal to 2 by 3 mr square. Noted? Moment of inertia and angular momentum. The moment of inertia of a rigid body about an axis is numerically equal to the angular momentum of the rigid body when rotating with unit angular velocity about that axis. Formula: kinetic energy of rotation equal to half I omega square. This formula gives a relation between moment of inertia and angular momentum. Kinetic energy of rotation is half I omega square. And moment of inertia and kinetic energy of rotation. Moment of inertia of a rigid body about an axis of rotation is numerically equal to the twice the kinetic energy of rotation of the body when rotation with angular velocity about that axis. That is, kinetic energy of rotation is half I omega square. Next, moment of inertia and torque. Moment of inertia of a rigid body about an axis of rotation is numerically equal to the external torque required to produce a unit angular acceleration in the body about the given axis. That is, tau equal to I alpha. Tau equal to I alpha. Okay. Next, law of conservation of angular momentum. If no external torque acts on a system, the total angular momentum of the system remains unchanged, constant. Mathematically, I omega equal to constant. I omega is constant, or I1 omega 1 equal to I2 omega 2. That is, when I increases, omega decreases. I is inversely proportional to omega. Here I is inversely proportional to omega. Provides no external torque acts on the system. For translational equilibrium of a rigid body, F equal to summation I Fi equal to 0. Same way for rotational motion. What force in translation motion? In rotational motion, torque. Tau equal to summation I tau I equal to 0. Okay. And this is a table between the linear motion, rotational motion. In linear motion, distance or displacement. In rotational motion, angle or angular displacement. This is the distance or displacement as S, angular displacement theta. What is the unit? What is the unit of distance? Meter. What is the unit of angular displacement? Angle. What is the unit of angle? Symbol for angle is theta. Unit of angle. Plane angle, solid angle, there we studied. How we are measuring angle? Yes? Degree. But degree is not a SI unit. So there is a relation between degree and that one. Or radian. What's the relation between radian and degree? Pi radian equal to 180 degree. Okay. This only gives the relationship between degree and radian. Wherever, suppose formula is in any given quantity, value is given in degrees, you should convert into radian. That is a 90 degree, for example. Example, I will do one problem, 90 degree. Convert into radian. I will convert into radian. Pi radian equal to 180 degree. Then 1 degree equal to pi radian equal to 180 degree, or 180 degree equal to pi radian. Then 1 degree equal to pi by 180 radian. Okay. Then 90 degree equal to pi by 180 into 90. What you are getting? Pi by 2. So 90 degree is converted to radian means pi by 2. Okay. Pi by 2 radian. Okay. Now, linear velocity v equal to ds by dt. What is that? Rate of change of displacement. What is the unit? Unit of velocity? Come on. Velocity, meter per second. Angular velocity, radian per second. Okay. Linear acceleration, rate of change of velocity, dv by dt, or d square or by dt square. dt square, this one, dt square. Then, what is the unit for acceleration? Meter per second square. Unit of angular acceleration, radian per second square. Mass, unit of mass is kilogram. Unit of moment of inertia, just now only we studied, I equal to mr square formula. So, kg, kg m square. Okay. This is a unit for moment of inertia. Noted? Force, F equal to m into a. Unit? Newton. Torque tau equal to I into alpha. Unit? Newton into meter. Because we said no, tau is nothing but force into perpendicular distance. Is it so? As r cross f we studied. In vector notation means r cross f. So, f into distance, that is n into m, nm. Okay. Also force F equal to dp by dt. What is that? Rate of change of linear momentum. Same way torque tau equal to rate of change of angular momentum. And translational kinetic energy equal to half mv square. Unit? Joules. Rotational kinetic energy half I omega square. This unit also joule only. And work done, F into S, force into displacement, joule only. Work done here also W equal to tau into theta. Instead of F, tau. Instead of S, theta. This unit also joule. And unit of power, F into V. Unit watt. And here unit of power, tau into omega. Wherever F, tau. Wherever here, omega. Unit watt only. Okay. Noted? Linear momentum of a system is conserved when no external force acts on the system. And Angular momentum of a system is conserved when no external torque acts on the system. Okay, both are constant only. Law of conservation of linear momentum, law of conservation of angular momentum. It is applicable only when no external force acts on the system. Here, when no external torque acts on the system. And equation of translatory motion, that is V equal to U plus AT, S equal to UT plus of AT square, V square minus U square equal to 2AS. And same way for rotational motion, omega 2 minus equal to omega 1 plus AT or alpha t here. And here U and V are the initial velocity. What is A? U is the initial velocity, V is the final velocity. What is A? Uniform acceleration. Okay, because this is applicable only for uniform acceleration. This equation of motion is possible, valid only for uniform acceleration. Same way here, uniform angular acceleration, omega 2 equal to omega 1 plus alpha t, and theta equal to omega 1 t plus 1 by 2 alpha t square, and omega 2 square minus omega 1 square equal to 2 alpha t. And here alpha is the angular acceleration, omega 1 is the initial angular velocity, omega 2 final angular velocity, and theta is the, what is theta? Theta is angular displacement. Okay. Next chapter, gravitation. Gravitation is the name given to the force of attraction acting between any two bodies of the universe. Newton's law of gravitation states that gravitational force of attraction between two point mass of the body in the universe is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. That is F equal to G into M1 into M2 by R square. And here G is the universal gravitational constant. M1, M2 are the masses or distance between the two masses. So F equal to G into M1, M2 divided by R square. This is the force of attraction between any two objects, two masses. F equal to minus G M1 M2 by R square in terms of vector represented by R cap. What is R cap? It is the, R cap is the unit vector. What is the value of unit vector? Unit vector R cap equal to R vector by modulus R or magnitude R. Okay. Then gravitational constant. G is a gravitational constant is equal to the force of attraction acting between two bodies each of unit mass. Unit mass means M1 equal to M2 equal to 1 kilogram, whose centers are placed unit distance apart, 1 meter distance apart. Then value of G is constant throughout the universe. So it is also called as universal gravitational constant. And it is a scalar quantity and dimensional formula m power minus 1, L power 3, T power minus 2. SI unit is n m square kg power minus 2 and its value G equal to 6.67 into 10 power minus 11 n m square kg power minus 2. And in dimensional formula, this question is very important dimensional formula because many places this is asked. That is following physical quantity as negative dimension of mass. Means m power minus 1 is a negative value. Only this gravitational constant only I think having negative value, m power minus 1. All the things may be having positive. Value 6.67 into 10 power minus 11 n m square kg power minus 2. Okay. Noted? Gravity. Gravity is the force of attraction exerted by Earth towards its center on a body lying on or near the surface of Earth. Gravity is the measure of weight of the body. The weight of the body of mass m equal to mass into acceleration due to gravity m into g. Yesterday I asked the question, no, what's your weight? You said 75 kilogram. I said that is not a weight, that is mass. Weight is nothing but mass into acceleration due to gravity. As m is 75 into 9.8 or 10. So the unit of weight of a body will be same as that of the force. So your weight can be measured in Newton or kilogram force also, or kilogram weight. Okay, that is unit of weight will be in Newton or kilogram force or kilogram weight. Newton or kilogram force or kilogram weight. Same as equal to Newton. Kepler's first law of motion, also called as law of orbit. Every planet revolves around the sun in an elliptical orbit, and sun is situated at one end of the focus of the ellipse. For circle, there will be a one center point, is it so? If it is circle, there will be one center point or one focus. For ellipse, there will be a two focus or two, just like two center point. That only we are calling focus. Okay, and all the planets revolve around the sun in an elliptical orbit only, with sun at one end of the focus. For example, for Earth, sun will be here, this focus. For other planet, sun may be this focus. But whatever, sun is situated at one end of the focus. And that is only Kepler's law of planetary motion, also called as law of orbit. Kepler's second law is also called as law of areas. That is, the radius vector drawn from the sun and each planet sweeps out equal areas in equal intervals of time. That is, the aerial velocity of planet around the sun is constant. That is, see, this area and this area is equal. And this distance and this distance, compare this. Is this distance and this distance same? No, this is larger distance, this is smaller distance. So for this larger distance, Earth has to travel faster and here slower. Time taken will be same. From year to year also 1 month, year to year also 1 month. How is possible? Here it moves very fast and it moves very slow. So based on this only, aphelion and perihelion. Or for satellite, apogee, perigee, that we will do. And so this is law of area. Kepler's second law is also called as law of area. That is, each planet sweeps out equal areas in equal intervals of time. It's not distance, area. This area equal. And this area as per the month, this area, December to January, this distance. February to March, this distance. And this area is a white shaded portion. White shaded portion is the area, is having equal area. Distance is different, but area is same. Time taken also same. This is law of areas. Next, law of periods. The square of the time period of revolution of a planet around the sun is directly proportional to the cube of the semi-major axis of its elliptical orbit. That is, t square is proportional to a cube. Suppose this is the ellipse and there will be a two thing. This is major axis and this off is semi-major axis and this height will be minor axis. Okay, that only semi-major axis. Where A is a semi-major axis of the elliptical orbit of the planet around the sun. And out of these three, only here only we will use problems. T square is proportional to a cube or r cube. And t square is proportional to a cube, or t square by a cube is constant for all the planets. All the 8 planets. Mercury, value of A, value of T. For Earth, 15 into 10 power 10 meter, and year 1 year is compared with a year. Okay. And see, t square by a cube will be around 3 point something or 2.9 something is constant. This only t square is proportional to a cube. Okay. Acceleration due to gravity. It is defined as the acceleration set up in a body while falling freely under the effect of gravity alone, and it is a vector quantity. Value of g changes with height, depth, rotation of earth. The value of g is 0 at the center of earth, and its value is g equal to gm by r square. Note down this formula. This is the value of acceleration due to gravity. G equal to gm by r square. Small g is the acceleration due to gravity. Capital G is the universal gravitational constant. M and R are the mass and the radius of the earth. M is the mass of the earth and R is the radius of the earth. 9.8 small g. Value of g on the surface of the earth is 9.8 small g. Capital G is 6.6. 10 power minus 11. It is constant throughout the universe, and value of g is differ from one planet to other planet. Even on earth itself, at polar region it may be one value, at equatorial region one value, and approximately 9.79 something or 9.8. Okay, this is acceleration due to gravity of the earth for earth. For Jupiter, higher than this. For moon, lesser than this. Value of acceleration due to gravity, effect of altitude, that is, when height increases, how is the value? G dash equal to g r square by r plus h whole square, or in terms of small g means g dash equal to g into 1 minus 2h by r, and here h is very very less than r. First is valid when h is comparable, and second formula is comparable when h is very very lesser than r, that is h is just some meter, r may be in 10 power 6 meter. So if r is very very greater than h, then we will write this formula. If r and h are comparable, this formula. And value of g decreases when height increases. H is a height or altitude. When altitude increases, g value decreases. Okay. Depth. If you go depth inside, g dash equal to g into 1 minus d by r. And depth also, when depth increases, acceleration due to gravity decreases. And effect of rotation, g dash equal to g minus r into omega square cos square lambda. Lambda is just like angle, and at the equator lambda equal to 0. That is, this is the formula, g dash equal to g minus omega square re. And at pole, lambda equal to pi by 2. See, its value 2 means how much? 90 degree. Then, if the lambda is 90 degree or pi by 2 radian, then g dash equal to g. Okay. Here omega is the angular velocity. Angular velocity of the earth. So depends upon the angular velocity of the earth, g value changing. Okay. Gravitational field is a space around a material body in which its gravitational pull can be experienced by other body. Formula, note down this formula, E equal to gm by r square. E equal to gm by r square is equal to acceleration due to gravity. It's just like electric field. What is electric field? Region or space around a electric charge where it experiences a force. What is magnetic field? Region around a magnet where it experiences a force. Same like that, space or region around a body where it experiences a gravitational force or gravitational pull. That is the gravitational field. Formula E equal to gm by r square. Gravitational potential energy, U equal to minus gmm by r. M is the mass of the earth and small m is the mass of one body. So gravitational potential energy equal to minus G_m_m by R. Okay, G_m_m by R. Gravitational potential is work done per unit mass. Electric potential we studied. What is electric potential? Work done per unit charge, no. W by Q. V equal to W by Q. Same like that, V equal to W by M. There we studied as test charge as Q naught. Here test mass M naught. And what is gravitational potential? Is the amount of work done in bringing a unit mass from infinity to that point without acceleration or against the gravity. Your negative sign indicates that its work is done against the gravitational force. That is negative sign. Next, gravitational intensity or electric field. In electric field intensity relationship, E equal to minus dV by dr. Same like electric field. Electric field E equal to dV by dr. Electric field intensity and electric potential. Same like that here, gravitational intensity or electric field and gravitational potential E equal to minus dV by dr. Satellite. A satellite is a body which is revolving continuously in an orbit around a comparatively much larger body. What is the name of the natural satellite for Earth? What is the name of the natural satellite for the Earth? Artificial satellite? Any artificial satellite name you say? INSAT 1A, 1B, lot of satellite they launch, no. These are all artificial satellite by rocket. Natural satellite I am asking. Natural satellite. Moon is a natural satellite. Okay. Moon. Orbital speed of satellite, see what is satellite? It is a body which is revolving continuously in an orbit around a comparatively much larger body. Moon is a smaller body or particular size of the body which comparatively revolve on the Earth. So moon is a one satellite. Orbital speed of a satellite is the speed required to put the satellite into given orbit around the Earth. Omega naught equal to Gm by R plus H whole power 3 whole power 1 by 2. Or in terms of G, R into G by R plus H whole power 3 whole power 1 by 2. And its time period T equal to 2 pi by omega and frequency nu equal to omega naught by 2 pi. And VO, what is VO? VO is the orbital velocity. Orbital velocity of a satellite equal to Gm by R plus H. G is the gravitational constant, M is the mass of the Earth, R is the radius of the Earth, H is the height of the satellite from the Earth's surface. And small g is the acceleration due to gravity of the Earth if satellite revolve around the Earth. Okay. Gravitational potential energy we discussed, U equal to minus Gmm by R, and it is negative. Kinetic energy of a satellite, this adult problem will work out. Kinetic energy of a satellite K equal to half m VO square. VO is the orbital velocity that if you substitute Gmm by 2R. And total energy of a satellite is U plus K equal to minus Gmm by 2R. Here R is the radius plus H, radius of the Earth plus height of the satellite from the Earth's surface, that is small r. Negative sign indicates that it is the binding energy of the satellite. Binding energy means attractive force. Total energy of a satellite at a height equal to radius of the Earth is given by minus Gmm by 2 into R plus R as Gmm by 4R equal to 1 by 4 into mgr. And here G equal to Gm by R square, that is the acceleration due to gravity on the surface of the Earth. When the total energy of the satellite becomes 0 or greater than 0, the satellite escapes from the gravitational pull of the Earth. Total energy of satellite becomes 0 or greater than 0, satellite escapes from the gravitational pull of the Earth. So to hold that one means it should be having some negative value, less than 0 as negative value. 0 or above 0 means the satellite will be shooted from the Earth gravitational field. Shape of a orbit of a satellite. If the velocity of a projection or velocity of a satellite is less than VO, that is, satellite falls back to Earth following a spiral path. Actually, satellite, how is it? Using a rocket, it should be taken to certain height and it will be projected with certain velocity. And that velocity should be compared with the orbital velocity. And if the velocity is less than orbital velocity, then the satellite falls back to Earth following a spiral path. Spiral path means spiral or helical path, like this, and then it fall down. Okay, that is, suppose Earth is here and satellite is shooted here and it follows a spiral path like this and then it falls like this. Okay, then if V equal to VO, satellite revolves in a circular path or orbit around the Earth. Okay, V equal to VO. If the projected velocity is equal to orbital velocity, then it follows a circular path. And if V is greater than VO but less than escape velocity will study, then satellite shall revolve around the Earth in elliptical orbit. Neither circular nor falling as a spiral, it is a elliptical orbit. Okay. And what is escape velocity? It is a minimum velocity with which a body must be projected in the atmosphere so as to just escape from the Earth's gravitational force or attraction. That is called escape velocity. V equal to √2 gr, where r is the radius of the Earth, and for Earth value will be how much? V equal to for Earth 11.2 kilometer per second. If you are possible to run 11.2 kilometer in 1 second, then you will escape from the Earth's surface. Relation between orbital velocity and escape velocity, V equal to √2 times of VO. V is the escape velocity, √2 times of VO. And there is no atmosphere on the moon because the escape velocity of the moon is low. Because the mass of the moon is low. As the mass of the moon is low, then G value will be low. As G value is low, escape velocity will be low. So it can easily escape. Geostationary satellite or parking orbit. Time period will be 24 hours. Geo means, geo represent Earth. Stationary means fixed. For example, there is one satellite fixed for Chennai. Then, at any time it is always facing Chennai. It means, what is the meaning? The rotation of the Earth and revolution of a satellite will be same. Okay. That is, angular velocity of satellite must be in the same direction as that of Earth. It thus just revolves around Earth from west to east. Its relative angular velocity with respect to Earth is 0. It facing same Chennai. Orbit of satellite should be circular. And orbit should be in equatorial plane and it contains center of Earth as well as equator. And this is very important. It should be at 36,000 kilometers from the surface of the Earth. For geostationary satellite means 36,000 kilometer height. If you fix a satellite at 36 kilometer height from the Earth's surface, then it follows the geostationary orbit. Its time period will be 24 hours, 1 day. A satellite revolving in stable orbit does not require any energy from an external source. Then the work done by the satellite in completing its orbit is 0. Acceleration due to gravity is used up in providing centripetal acceleration to the satellite. Hence, effective G inside the satellite is 0 and orbital velocity is 3.1 km per second and angular velocity 2 pi by 24 radian per hour. Orbital velocity 3.1 km per second, angular velocity 2 pi by 24 radian per hour. Not second, per hour. For a satellite orbiting near Earth's surface, time period 84 minutes. Orbital velocity 8 km per second. Angular speed 0.0125 radian per second. And inertial mass and gravitational mass. Inertial mass is the force per acceleration. Gravitational mass is weight of the body by acceleration due to gravity. F equal to ma no, in their mass is inertial mass. And F equal to m into g, in that g we will use acceleration to gravity, that mass is gravitational mass. And both are equal in magnitude, but difference is gravitational mass is affected by presence of other body nearer to it, but inertial mass does not affect by other body nearer to it. That is the only difference. Weightlessness in a situation where the effective weight of the body becomes zero. Yesterday we discussed, that is when in giant wheel or in lift, when you are falling down freely, then we feel weightless. When the body is taken at the center of the earth, we feel weightless. When your body is lying in a freely falling lift, without under the tension of a cable, weightlessness, A equal to G. And when the body is inside a spacecraft or satellite which is orbiting around the earth, we feel weightless. Okay, next chapter, mechanical properties of solids. Mechanical properties there, elasticity is a property we are discussing in their deforming force. What is deforming force? A force acting on a body which produces change in its shape of a body instead of its state of rest or uniform motion. And what is elasticity? Elasticity is the property of a matter by virtue which it regains its original shape and size when the deforming forces are removed. For example, rubber band. Rubber band, if you stretch, it will extend the length. If you leave it, what will happen? It come back to original position. That is the elasticity. It's a property of body which can regain its original shape or size after the removal of deforming force. And if it does not come back to original position, that is called plasticity. Hooke's law. Hooke's law states that within elastic limit, stress is directly proportional to strain, or stress by strain equal to constant. Stress by strain equal to constant. This is Hooke's law. Within elastic limit, stress is directly proportional to strain, or stress by strain constant. Stress is nothing but restoring force per unit area. Its unit Newton per meter square or Pascal. And its dimension formula you should find from A, B, C and all. We will work out now. Dimensional formula for force is m L T power minus 2. Area, what is the dimensional formula for area? L square. So L square getting cancelled, then m L power minus 1 T power minus 2. This is the dimensional formula for stress. Okay. What's the dimensional formula of stress? M L power minus 1 T power minus 2. And different types of stress are there, that is normal stress and tangential stress. Normal stress means that classified into tensile stress, where there is an increase in dimension of body along the direction of force. Compression, decrease in dimension, that is a normal stress. Tangential stress, acting along a tangent, that is surface of the body, that is tangential stress. Strain. Strain is the ratio of change in dimension to the original dimension. That is longitudinal strain, change in length by original length. Volumetric strain, change in volume to the original volume. Shearing strain, delta L by L. Delta L is the displacement of the face. L is the height of the face. It's a shearing. Hooke's law we discussed, stress by strain equal to constant. And there are three types of moduli. Young's modulus, normal stress by longitudinal strain. Bulk modulus, normal stress by volumetric strain. Rigidity modulus, tangential stress by shearing strain. That is rigidity modulus. And all are having same unit. What's the unit of modulus? Newton per meter square. This is the unit of all the three type of moduli. Compressibility. Compressibility is the reciprocal of bulk modulus, that is compressibility equal to 1 by K. Elastic limit, maximum stress which can be applied to a wire so that on unloading it return to its original length. That is called elastic limit. Young's modulus we discuss as longitudinal stress by longitudinal strain. This is the Young's modulus. L is the length of the material, and by applying force there will be a change in length. Change in length by original length will be strain, and stress will be force by area. On simplifying we will get. And higher the Young's modulus, elasticity will be more. Rigidity modulus, tangential stress by shearing strain. Tangential means force acting along the surface. So there will be a change in the theta value. Based on that we will derive. That is the rigidity modulus or shearing modulus. Bulk modulus, change in volume to the original volume. Capital V is the original volume, small v is the change in volume. Based on that we will simplify. And reciprocal of bulk modulus is compressibility. Stress strain diagram. That is when stress increases, strain also increases, and up to OA there will be a proportionality limit. It acts as a elastic nature. And up to B there is an elastic limit. Up to B, if you remove the stress, body can come back to original position. Beyond B and C, it is the partially plastic, partially elastic. Beyond C, it is a plastic behavior. After D, fracture point or end point, breaking point. Beyond D, if you apply a force, then the wire will be break or material will be under breaking stress. In stress strain diagram, these things are all important terms: proportionality limit, elastic limit, yield point, plastic region, fracture point or breaking point, and work done equal to half into stress into strain. Note down this formula: energy per unit area or unit volume of the strain, or work done per unit volume equal to half into stress into strain. And Poisson's ratio is the lateral strain by longitudinal strain. Symbol for Poisson's ratio is sigma. Sigma equal to beta by alpha. Beta is the lateral strain and alpha is the longitudinal strain. Okay. Sigma is the Poisson's ratio, beta is the lateral strain, and alpha is the longitudinal strain. Alpha equal to beta by alpha. And this gives the relationship between three moduli of elasticity and Poisson's ratio. And here, this is this formula, C formula only gives the three moduli of elasticity. 9 by Y, 3 by N. N is a rigidity modulus, K is a bulk modulus. Okay. And some formula we want to learn: work done per unit volume off into stress into strain, and energy density is nothing but energy per volume, so off into stress into strain, or work done is off into stress into strain into volume. This volume goes there, and off into stress into strain. Based on that Y value or strain as X value, like the different formula, based on that we will do some problems. And typical elastic modulus of some substances. See here, which material having highest Young's modulus? Steel. Steel is having highest 20 into 10 power 10 Pascal. And next is iron, I think. Is it so? Copper 11, iron 19. Steel is the highest one. That is why in roof and all we are using steel rod or iron rod. Okay, that is only having highest elastic moduli. Bulk modulus in there, comparison of bulk modulus, which is highest, mercury is having highest one. And elastic limit ultimate strength. Here also I think steel is having highest. 2.5, 10 power 8 Pascal, tension 5, compression 5. Steel is having highest. Okay. Okay. Thank you, students. In next session, we will start next chapter in this session. Thank you. Thank you all.